Hello everyone, this is V. Manikyala Rao, working as assistant professor in the department of CSE and ML in BVRIT Nasapur. So now today we want to discuss about the another hierarchical clustering method, that is divisive clustering algorithm and BIRCH algorithm. So what is divisive clustering algorithm? Divisive analysis clustering algorithm. So divisive analysis clustering algorithm means, for example, if I want to take the clusters like A, B, C, D, E. These are the clusters I taken here. So divisive means the A, B, C, D, E will be divided into individual ones, individual clusters like this. This is called as dendrogram for divisive. All whatever the clusters are there, each and every cluster is divided into individual parts based on the calculation process of dissimilarity values in the divisive clustering algorithm. So now these are the steps to implement in the divisive clustering algorithm. One by one I will explain. So coming to first one, initially we have to initialize the cluster values. So let us assume that this is our example. We are taking the example this one. So this contains 5 values, that is A, B, C, D, E. So first we have to initialize the cluster with that values A, B, C, D, E. Then we need to initialize Ci to C1. So that means Ci value is our cluster value, Cj value, let us assume that Cj value is a pi value. By applying the process, we need to implement these A, B, C, D will be moved into Cj. Now the next step means we have to calculate the average dissimilarity between the points by using the iterations. Average dissimilarity means one, for example, average dissimilarity of A means, so we are calculating for A, so we don't want to count for A. So other remaining variables are B, C, D, total 4 variables are there. So 1 divided by 4 into distance of A to B, then A to C, then A to D and A to E. So A to B distance is 1 plus A to C distance 2 plus 3 divided by 4, so that is 2.0. That is the distance similarity of A. Similarly, average dissimilarity of B, so that is here also we are does not consider B, means the other 4 variables are there. So 1 by 4 into, so B to A, B to C, B to D and B to E. So that values we are substituting, we are getting 2.5. Then similarly, average dissimilarity of C value, same value we are calculating, so that value we are getting as 2.0. Next, dissimilarity of D, so that point we are getting 2.50. Dissimilarity of E, so that value we are getting 3.50. So out of these all the values, whatever is having the minimum value, we need to consider that one. Now C. So out of these all the values, we are having the highest maximum value is 3.50. Now actually in CI we are having ABCD, but E is having highest similarity, so then we moved into CJ. In starting we are taking Cj value to pi. So now we are replacing the Cj value with E. Why? Because E is having highest average similarity compared to all other values. That's why we are moving E into this one. So next we need to check whether any A, B, C, D, E will be moved into the existing Cj or not. So how to calculate means, we need to calculate distance between the object dx is equal to average dissimilarity of E with respect to Ci, dissimilarity of x with Cj. So that means the distance from whatever we are taken, so dA means other than E will be, E is already removing from the C structure. So that's why, so distance from A to B, A to C and A to D minus A to E. So dissimilarity of x with Cj, that means E value. Dissimilarity of x with Ci means ABCD values. So we are substituting that value, we are getting that value is 1.33. Like similarly, distance of B, C and D. Now the next step what we have to do means, in case in these all the values, if we are getting any greater than 0 value, we need to include that greater than 0 value into Cj. In case those all the values are less than 0 means, again we need to calculate the same step of process, average dissimilarity between A, B, C, D. So now I will show you one by one. So E is already done, A, B, C, D is there. So now again we have to do the same process. We will take only A, B, C, D and implement the average dissimilarity of A, B, C, D. So A is already considering, so we are having only 3, B, C, D. So that 3D we are taken and that values we are getting 1.67 and similarities 2.33 and 1.67. And finally average dissimilarity of this one 2.33. These all the values are greater than 0. And now coming to this one, out of this A, B, C, D, the highest value is for B 2.33. So now we will consider this one into our B. Then the B Cj, now our Cj contains the values are B and E. Ci contains only A, C and D. These all the values are there now up to now. Now next we have to do the same process in case any SCD will be moved into our structure or not. So we need to calculate the same dx dissimilarity of Ca minus dissimilarity of Cj. So from A to C, A to D, then A to B. So that values we are getting, so 1.0 minus 0.5 minus 2.5. Out of these values, so this value is greater than 0. So already given, if that is less than 0 means we need to calculate again, if that is greater than 0 means we need to include into Cj. So now our Cj values are B and A. Ci values are C and D. E is already included into our set. So next we have to do the same process. Any CD will be moved into Cj or not. So now I will do the same process. So next A, B, C, D, E like this. Why? Because we are at the end of the stage. So that's why we are framing the endogram like this. See here. So Ca contains CD and Cj contains BA. So that values we need to include here. So A, B, C, D and E. So finally this E will be combined with CD and AB. Our form is A, B, C, D, E. Whatever the data set we are taking. So like this we are doing the same process for the divisive clustering algorithm. So in this way we are dividing that one into the clusters, individual clusters. The next method, BIRCH method. BIRCH method means balanced iterative reducing and clustering using hierarchies. So in the BIRCH method what we are doing means we need to iterate the process until the last. So these are the steps we are taking here. So first we have to load into the memory by using CF tree. So CF tree means contains N, LS, SS. CF structure contains. CF means clustering future tree. So N means the number of data points, LS means the linear sum of values and SS means sum of square values. And then based on the tree we have to write the divisible CF tree with the leaf nodes. And what leaf nodes we have to be considering, whether it will be moved into the CF, and finally we need to frame the clustering group, that group we are framing, and finally we have to frame the final structure for this one. I will show you one by one with example, you will understand what is happening in this. So now coming to the first one, let us considering the points, 10 points I taken here. So the threshold value I taken as 1.5 and the maximum branch value contains only 2 branches we need to take. Here the meaning of threshold means whether the given condition reach with less than with that particular value means we need to include our tree. In case that is greater than that value means we need to include that one into the another leaf node for the same root node. So I will show you with one by one. So first I taken considering the data point 3, 4 with that. So 3, 4 it does not have any other values, it has only 1 point, so the radius value will be 0. So n comma ls comma ss. So n means it contains only 1.34 for x1. So ls linear sum value 3, 4. Then sum of squares value means 3 square plus 4 square. So that is 916. So our CF value means n comma ls comma ss, sum of squares n, ls and ss. So our CF1 value. The leaf node for this means what point we are calculating CF for 3, 4. So that 3, 4 leaf I written here. Next we will do the same process for x2. So in x2 what we are having, x2 is having 2 values. In previous x1 is also there with x2. So 3, 4 plus 2, 6. So that value is 5, 10 and the sum of squares value 13, 52. And now we are adding that 5, 10 and 13, 52. Again we need to calculate the radius calculation. So radius calculation means sum of squares minus linear sum square divided by n. So 1352, so our value 1352 minus 510 square divided by 2. So that value 0.5 comma 1. So it value is less than t. Why? Because t value we are given as 1.5. So this value is less than threshold value. That's why we are including x2 into our data set. Now CF value will be increased into 2 with these values. Why? Because CF is having 2 values, that is x1 and x2. Now similarly Same process we have to do for x3. So the CF value will be increased into 3. So we are having the previous values, these sum of values plus this value. So 510 plus 4 5, so that is 915, and finally 2977, this sum of square values, and finally we got that the number of points are x1, x2 and x3, and then we need to calculate the radius value. So radius value ss minus ls square by n minus n. So that is, this value is also less than threshold value, we are including x3 into our CF tree. Similarly, the same process is doing for x4. So same x4 we are including and CF value included. So that value we have to be included into, why? Because this radius value is less than threshold value. Next, the same process we have to do for this one, x5. So 54, 190 and 1630 is there. We are calculating this one, 0.33 and 0.63 is less than 1. So now x5 is also moved into our structure. These are the CF1 value. Now we will move into the next x6, this value. So in this we are getting the value 2232 and 9194. After substituting, we are getting that values 1.24 and 1.97. So actually our threshold value is only 1.5, but here we are having greater than 1.5 value is there. That's why this condition is false. So now we are moving, they are giving the maximum branch is only 2 branches only, they are having 2. So that means we have to take the same CF with CF2 if the points are 6 to. Why? Because this value is a greater value. That's why we are taking the another CF2 value with this 6 to value and with this 36,4 value and include that one into second leaf with the same branch. So we are considering this as only 2 branches and considering this is also having only 2 branches. So they need to follow the method like this. CF1 is previous values as it is to be there. So next same process we have to, whether the next we have to calculate for x7. x7 will be moved into CF1 or CF2 we need to calculate. So we are calculating for that, we are having the two methods CF1 and CF2. CF1 means LS by N. So LS means linear sum value. So 1630 by y. So that is 3.2, 6 and this value 6, 2. So finally x762 is closer than 3.62, 6. So that's why we are including x7 into CF2. Why? Because these values are higher values. So now we will consider that one and again we need to calculate the same process and x7 is to be included into our method. That is a x7. Same method. So here the value 0.5, 0. So it is less than the threshold value. Now we are including that one into CF2. Next, the same method we have to do, we have to calculate CF1 and CF2 and this values also near to that values, that's why we are including that one into x6 similar to CF2. So F2 CF2 value will be increased to 3 in the next conditions. So that CF2 value will be increased to 3 and linear sum value and that value we are written here. So finally x8 will be included into this one. Same we have to calculate for x9. So that values also, these values are near to these values. So that's why we need to include this one into the CF2 tree. So that value will be increased into CF2 as 4 for this one. Similarly, the same process, the x9 is also moved into this one and the next one we have to do for the last step, that is x10 is equal to 7, 9. So x10 value we need to calculate. So same, this value is also greater value compared to this x6 value. So now we need to include this into the CF2 tree. So CF2 value is to be increased into 4 to 5. So our CF1, CF2 value will be increased into 4 to 5. Then again we are taken CF3. Why we are taken means that value in this value is a higher value. That's why we are taken that one into CF3 value. The CF3 contains 7n. Why? Because this value is a higher value compared to that one. So that's why we are dividing that one into CF1, 2 and 3. Only 2 branches. Here also 2 branches will be there and here also 2 branches will be there. Here also 2 only will be there. So like this we are dividing x10 into 7 and why? Because this value is a 2.56 is a higher value. So that's why we are combining CF1, 2 with CF3. So like this we are combining the methods in this. So this is about the BIRCH algorithm. This is one of the type of hierarchical clustering algorithm. This is about the BIRCH algorithm in the hierarchical clustering algorithm. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.